Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about Astable multivibrator circuit design using 555 timer IC. This is the fifth tutorial of practice projects for absolute beginners or practice projects for PCB designers. I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder, and I am going to teach you today how to design a Astable multivibrator circuit. So let's get started with our product development cycle. In this tutorial, I'm not going to focus on how to go with a black box analysis or a white box analysis. Why? Because in the beginning only, we are decided to use NE555 timer IC. That's why there is no sense to do a black box and a white box analysis. However, I am more focusing on the calculations and circuit design in this particular tutorial. First thing is, we need to understand what is the circuit diagram for NE555 timer, especially for a Astable multivibrator. Because there are other two configurations like monostable and bistable multivibrator design using the same IC. So make sure that you identify a stable multivibrator circuit, which is just like this one. R1, R2 resistor and a capacitor and also a decoupling capacitor, all that thing. In this particular circuit, we need to calculate the components value before going for the circuit design or maybe a schematic capture. That's why we need to understand what exactly the formula for calculating the component value. First thing is, we need to understand what is the total time period we want at the output side. If we are creating a stable multivibrator which is having pulses and spaces, then we need to understand what is the total time period for the pulse and total time period for the space. These are called pulse width and space width. Together, it is so called total time. Again, if you inverse this total time, it is nothing but a frequency. So what is the frequency of your output signal coming from the Astable multivibrator? Based on that, you are going to use this T on formula and T off formula to compute the R1 and R2 resistance. However, we are going to assume a capacitance for the standard value. This is what we need to do with respect to a 555 timer IC based Astable multivibrator circuit. Here we need to understand datasheet analysis is very essential if you are designing a high voltage Astable multivibrator. For example, 24 volt DC. Because on that time, you need to select a specific part number IC which is suitable for 24 volt DC with a current rating that you are expecting. Now let's jump into the calculation part. This is very simple once you understand, nothing so complicated. So just try to understand the concept here. The first thing is, we need to generate, or I'm assuming to generate a 2 seconds of a square wave or 2 seconds of total frequency, the time period of the entire wave, within which T on should be 1 second, T off should be 1 second. It's like a 1 second on and 1 second off cycle. In that case, I'm assuming a capacitor to be at 10 microfarad, which is very generally used in such kind of a circuit most of the time. 1 microfarad, 10 microfarad is the very common one. Now I'm considering a 10 microfarad one. So using these two information, we have a T off formula because that is the easiest one where we will get the R2 only variable and we can compute the R2 using all the information available with us. So T off is a 1 second, 0.693 is a constant and R2 value is yet to be computed. Capacitor is a 10 microfarad. And do remember, the capacitor I'm talking is this one, not this capacitor. This is a 10 nanofarad decoupling ceramic capacitor. So make sure that you add it by default. There is no way to change that value and there is no necessary to change that value. Thereafter, we'll be taking the R2 this side and 1 divided by 0.693 into 10 microfarad. We'll be ending up with a 144.3 kilo ohms. It's a simple calculation, nothing complicated. However, in market, 144.3 kilo ohm resistor is not available. That's why I'm going to assume, or I'm going to use 146 kilo ohm standard resistor for this particular application or for this particular resistance, R2. Using this R2 value and available capacitance value and the T on T off value, we are going to compute the T on now. So, the R1 value by using a T on formula. So T on is equal to 0.693 into R1 plus R2 into C, right? So here we'll fill all the information and we have R2 here. 1 divided by 0.693 into 10 microfarad goes in one side and that entire thing will be deducted from 146 kilo ohm by transferring from right side to the left side. Then we will be having a R1 at the one side. So if I do the proper calculation with the calculator or basic mathematics, then we will be ending up with a 1.69 kilo ohm resistance. However, 1.69 kilo ohm resistance is not standard value and not available in the market. That's why I'm going to use 2 kilo ohm resistor instead of 1.69 kilo ohm. This is how you are going to calculate the R2 value and R1 value, assuming C value and also assuming the T on and T off period with a total time period of 2 seconds. We'll verify these values, or we'll verify whether this one is correct one or not by using online calculators. Online calculators are very handy in such cases. One among them is ohmslawcalculator.com is a website within which we can calculate the value for the voltage divider as well as for the 555 timer Astable multivibrator. Again, this video is not sponsored by this website, but still, I love this website and I use it lot of time in our design work. That's why I'm giving you an example for that. Here we have a small description here. Just if you are interested, you can read that particular description. It is very valuable. Now I will put the capacitor value as a 10 microfarad. Make sure that you can set it to the microfarad instead of nanofarad. And then the resistance value is a 2 kilo ohm because R1 is a 2 kilo ohm in our case and R2 is 146 kilo ohm. If I do so, then frequency will be 0.5 hertz approximately and time period is 2.039 or 37 seconds. The difference of 0.037 is because of approximation that we did with the resistance. Instead of 1.67 kilo ohm, we selected a 2 kilo ohm, right? That is the reason why we have extra seconds here. And if I look at the duty cycle, it is a 50% approximately. And then time period, T1 or T0 or on period or off period is approximately 1 second. Again, 0.02 second, whatever the difference is visible to us here is because of the resistance approximation that we did because of standard value available in the market. This is how you are going to verify whether your design is correct or not. And then you are jump into the schematic diagram. So this is all about our the design activity and this is how our circuit looks like. Now let's jump on the Easy EDA software and start working on the schematic design. First of all, I will go to the Easy EDA and I will go to the file section and go to the project section and start writing a project. I'll name this one as a Astable multivibrator NE555. Okay. So you can give a description if you want, otherwise you can skip it. I'll click on save and here I will start doing the project as we always do. Now you can see here, we have two options of symbol. Again, in our every design, we will be dwelling between these two kind of options in most of the cases. First option is a standard IC design or a schematic symbol. Another one is a schematic symbol with all the standards, but only the thing is pins are configured or the placed in accordance with the design circuit. For example, if we have this circuit, then we need a 7th pin here, we need a 4th pin on the top side, 8th pin on the top side, 3rd pin on this side. So the architecture of the IC is accordance with the design that we want. So in such cases, it is recommended to use this kind of a schematic symbol rather than using this kind of a schematic symbol. So I'm going to use this one and design a circuit right now. Alright, now you can see that the circuit diagram is ready, or you can say schematic design is completed. I have used the input connector for connecting the VCC. I have not mentioned the specific voltage here. Why? Because it is dynamic from 4.5 volt to up to 35 volt. So whatever voltage you want to give, you can give here. That's why I have mentioned it as a VCC. And that VCC is connected to the VCC pin and reset pin of the IC along with the same circuit diagram that we discussed. Oh, I have forgot to mention the 10 microfarad here. So let me mention it. Okay. So after that, we have one resistor here. I would like to go with a 560 ohm resistance. Okay. And we have an output connector, which is helpful for us to take the output from the Astable multivibrator circuit. Okay. This is how the entire circuit diagram looks like, or the schematic diagram looks like. Now I'm going to jump onto the PCB layout design as we always do. All right, now we are almost done with our PCB designing. Of course, I have yet to complete with the designators and all. But here we have a small problem, and this is a great place for learning a new trick. That's why I'm explaining something here. You can see here one net, that is a ground net, yet to be completed. The way I have done the routing here is pretty simple and straightforward. If you follow the same process, you will also end up with the same problem. If not, at least you will end up with the one or other problem which requires the same solution. When you are having a problem with respect to the connection from one point to another point, which is not possible because of intermediate routing here, you can see here there is a one copper track here, because of which this path of the ground is not able to mix with a global ground. In that case, it's just not possible. The circuit doesn't work. If I leave it like this, the circuit doesn't work. Now I need to connect this point with this point in any of the way. That's why this rat lines are showing to me, or this rat line is showing to me, we need to make a connection from this point to this point. How can we do that? There are several ways for that. One way is using a top copper and completely routing a one copper track from this point to this point, which will be a very costly process. Why? Because in this entire PCB, just because of this one particular path, if you are using a top copper, then your entire production price or the PCB fabrication price will be very costly, because you are using a top copper and a bottom copper just for the one particular track. Instead of that, what we recommend is we use a jumper here. The jumper, in the sense, it's just like giving a 2 drill hole here, so that you can add a piece of wire from the top side after fabrication of the PCB, which is not good for the mass production. Of course, it is suitable for the prototyping activity only. In mass production, it is always better to use a copper track by using another layer of copper in the design activity itself. In the manufacturing only, it will be taken care. But right now, we know that this is a practice project for the PCB designer, and this is very suitable for the low-level manufacturing or low-cost manufacturing, you can say. On that time, what we are going to do is, we are going to use these pads. Can you see this one? There are pads option here. You can click a P button on your keyboard as well, which will bring the same option. So if I click on that, you will get the pad. It's a very big one. Why? Because we have selected recently pad with a drill hole and all. I'll place this pad somewhere here, and I'll just change the dimension of width to 1.5 mm and a drill hole to 1 mm. Okay, this is the standard pad that we use for the jumpers. I call these as jumpers because it will create a jump effect from one point to another point in the same layer. That's why. So I will place it somewhere here, and I make sure that it is a state. If you place it a little bit here and there, then it is not a good idea. Now, to make it easy for the software to recognize, I have resolved that error. Otherwise, it will not recognize. See here, still it is popping up the same error. To make it easy for the software to recognize, I have resolved that error. I'm going to add a top copper connectivity between those two pads. But actually, when you are manufacturing, you are going to tell your fabricator that we don't want this particular track. Instead of that, you want a small symbolical representation over there. By using a top silk layer, I'm going to add one small line here. You can see here. Okay, this is how the small line I'm going to add, which will be helpful for you to recognize. You need to add a small connecting wire on that when you are fabricating the PCB or when you are assembling the PCB. But in the fabrication process, you informally or you directly tell your fabricator that you do not need this top copper in the entire PCB. By doing so, you will be making this entire PCB in the single copper, and hence you will be reducing a lot of cost in the fabrication process. So this is how the problem will be resolved. Like this, we will get a lot of problem in the higher level of circuits and all. And if the circuit design is very complicated, say for example, you are having a more than 2 to 3 jumpers like this, then it is not at all good idea to go with the jumpers. It is better to use a 2-layer PCB designing and complete your entire PCB much better way. So just make sure that you are using it in the right place at the right time with a right intention, like do not making it too complicated for the assembly process as well. So this is how the jumpers are used. And now we'll be doing with the designators. So designators are also completed. So this is how our entire PCB looks like. Now let me add the silk layer or the legend screen with the information. So this one is the output actually. So I will write it as a OUT out, and I will make it as a 0.2 mm, 1.5 mm. I think it fits. Yes, here it is. It's possible to fit it here. And I'll copy and paste it, make it as a plus on the other side, this side, and copy paste and minus. So this is going to be this side. So this is an indication that this is a plus side and this is a minus side. And I'll be copying the same thing, pasting it this side. I'll name it as a in. Okay. Or we can name it as an input as well, but let it be. In is sufficient. So this is this is a minus side. This one is a plus side. So let me place the minus that side and plus this side. Okay, this is how you will give a VCC to VCC with respect to ground, and this is where you will get the output. And the iconic point is adding a name on the PCB. I will name it as a multivibrator for sake of simple writing over there. Is it possible to put an entire circuit here? Yes, it is possible. On track also we can place it, so no worries, we can place it. And then we'll be adding a hashtag linked frequency. Alright, so I'll just reduce it to 1 mm, 0.15 mm. Okay, so this is how, I think this is not aligned properly. Let me align it. Yes, now it is aligned. So this is how our entire circuit is designed. Now let's check for the DRC. Yes, all nets are connected, so there is no problem. And let's check for the DRC as well. There is no DRC error. So if I go to the 2D view, this is how our PCB looks like. Notice this particular part is having an exposed pad. If you are using a wires and all, then make sure that you expose them. If you are using a pad directly, then no need to worry about it. It is a straightforward and it is already exposed. And in case of a bottom side, if you look at the bottom side, you can see all the tracks and the pads are here. It's a very compact PCB, very good size. The size of the PCB is 40 mm by 35 mm. Very small one. In fact, you can make it as a 40 mm by 40 mm so that in the production, it is easy for the fabricator to fit entire circuit inside a single panel. It's a good idea to go with a symmetric design all the time if it is possible. And if I go to the 3D view, then you can see that the connectors are here. IC is not loaded because it is not having a 3D model probably. So this is how your entire circuit looks like. And if I turn it to green, this is how it looks like. So this is a compact Astable multivibrator circuit design using 555 timer. Again, after this, going back to the schematic, exporting the BOM and exporting fabrication file, the Gerber file, and anything that you want for the entire documentation or the production plan is as straightforward as it is we discussed in our previous tutorial. So this is how the entire Astable multivibrator circuit is designed using a 555 timer. So I hope you enjoyed the entire tutorial, and I'm believing that you are going to try this circuit by yourself and try to make it even more better if it is possible according to your idea and intuition. Thank you so much for watching this video, guys. See you again in the next video. Until then, practice all the projects that we discussed so far, and let me know if you have any questions in the comment section. I'm very happy to answer your question. Thank you so much for watching. See you again in the next video. Until then, tune yourself to make a difference.